You just may have heard this meeting is being recorded, so just be aware of that. If you're not consenting to being recorded, you can leave now, and you're welcome to watch afterwards online. But welcome here if you are here, if you are staying. Thank you very much. As I say, my name is Howard Neville. I'm a building services engineer with PM Group on the board of governors of ASHRAE Ireland chapter. And we're going to have a seminar today on advanced room air distribution strategies for effective airborne infection control. I think this is an incredibly interesting topic, and it follows on from the seminar that we had just before Christmas on air movement and capturing of infection control. Our panelist today will be Professor Chandler Shekhar. I'll let him introduce himself, but he's a program director, as it says there, of the MSc program for the Building Performance and Sustainability in the National University of Singapore. We're going to move on very quickly. I'll just do a bit of housekeeping and then I'll hand over to Chandra. And then we'll have some question and answers at the end. Okay. So if you have any questions during the program, down on the bottom right-hand corner, you'll see a chat function if you want to type in the question in there, and then we'll deal with the questions at the end. If you're having any difficulty, you can also email secretary at ASHRAE, and we keep an eye on that if that isn't working for you. We will have a handout up on our webpage after the seminar. But we can keep the conversation going. If you follow us on Twitter, or if you at us there, or you can follow us on LinkedIn if you have any comments afterwards, or you want to continue the conversation, because I appreciate this is a very interesting topic. So as I said, I'll hand over to Chandra now, and he can introduce himself, and we'll get on with the seminar. So welcome, Chandra.
Okay. Thank you, Howard, and thanks to the ASHRAE Ireland chapter for inviting me to speak at this webinar, and the topic that you chose, and I'm happy to share some of the work that we've been involved in for a good number of years now, 15 plus years, 20 years perhaps. Let me get the logistics in, share screen, press the button. I believe you're able to see my screen, and let me just get the, are you able to see my first slide?
Yes,
we're seeing it now, thank you.
Thanks.
Am I audible? Am I audible? Are you able to hear me well?
Yep, sound is great.
Great, let's get started then. The topic is on advanced room air distribution strategies for effective airborne infection control, as was just mentioned by Howard. I am a professor in the Department of the Built Environment at the National University of Singapore. I look after a graduate program in the area of building performance and sustainability. It's a master's program in that particular field. So without further ado, let me just get started with the few slides that I would normally have to do at this stage. This is the Distinguished Lecturer program that is brought to you by ASHRAE CTTC and the chapter. And you would perhaps be asked towards the end of the webinar to give your feedback. So appreciate if you can do that. It helps the program committee to improve as we go along with other topics in the future. ASHRAE, as most of you here may well be aware of, there's several ways in which you can get involved. There's the technical committees, the standards committees, and a whole bunch of other I suppose areas in which you may have an expertise, and if you are willing to find time and I suppose the place in which you can contribute and participate, it's always mutually beneficial. This is also certified by the USGBC certification program here. It's a 1-hour credit that you get if that's required as part of having attended this particular webinar. The handouts will likely be distributed to the participants. I'm not going to read everything that you see on the slide. So this is a description of what this talk is about if you want to sort of get everything in one abstract form. I have a few learning objectives that I have presented here. I will start with a little bit of backdrop about where we are in this COVID-19 pandemic in today's context, the evolution of it in the last 3 years. That's kind of setting the scene, specifically from the perspective of airborne transmission. Then we look at different types of room air distribution strategies and see how advanced room air distribution strategies can help us tackle this issue about uh, helping in the context of protecting people in occupied spaces in a building. In particular, in terms of the technology or strategy that we have been working with for some time, I will be introducing the topic of personalized ventilation and also combining that with personalized exhaust. So if you break it down into very simple terms, it's almost like saying, can I get clean air right up to the place where the person is? Can I extract the contaminated air right where the person is probably exhaling the contaminated air? If you spend a moment trying to understand what I just said, that is all there is to it. Source control. Can we enforce source control? Can we provide better ventilation in the occupied zone to every individual so that the occupant exposure can be better managed? And that's really, I suppose, at the bottom of it, that's really the technique or the strategy we should be striving to achieve. Um, as a quick overview, this was just pulled out not too long back on the 18th of January. I was giving another talk and I pulled out and saw that there were about 663 million cases, 6.7 fatalities worldwide. And this slide is just to get us a bit of an overview understanding of how the whole thing started back in early 2020. And then the evolution in terms of different waves that the world has seen, the alpha, beta back in December 2020, the gamma variant, delta, which was a huge problem globally. The Omicron has been there for the last about 14 months or so, and the various subvariants since then have seen different waves occurring in different places. And the main purpose for me to show this slide was to say that when it came to the transmission mechanisms, there was a lot of debate going on in the early days in 2020. However, there were certain groups, certain technical and professional societies like ASHRAE and REVA, they acknowledged that airborne transmission route is probably one of the important mechanisms that we should not ignore. Both ASHRAE and REVA, and likewise perhaps other technical societies worldwide, came up with timely recommendations or guidance for the professionals involved, the engineers, the building managers, the facilities managers, whatever they are looking after, to see how best they can manage the built environment from the perspective of the mitigating the airborne transmission risk. I've always maintained that if you acknowledge a problem, you can think about solutions, simple solutions, innovative solutions, or whatever that might be. In the early days, if you recall, there were recommendations from ASHRAE and REVA and elsewhere. Turn off your demand control ventilation, turn off recirculation, have 100% outside air. I think that's logical. I mean, the mindset will always be, why should I move the air from within the space that's potentially contaminated with the SARS-CoV-2 virus? At about the same time, in the early 2020 timeframe, there was this group of international multidisciplinary group of scientists. It came to be known as the Group 36. I was part of it. Some of my other colleagues from the international scientific community, you might recognize some of the names on this list here. We made the argument, or we made the case that, look, airborne transmission of COVID-19 is a very likely scenario, and we should strive to minimize that. And it led to further commentary in journals like the Clinical Infectious Diseases, where several other scientists who work in this field came to acknowledge the fact that, yeah, airborne transmission is something we can't ignore. There's a lot of research that you'll find published during this period in the last 2.5, 3 years, even as we speak, perhaps more are being brought to the scientific platform, all to do with the airborne transmission route as a means of SARS-CoV-2 transmission, and and I suppose a way to quantify the extent to which these are likely the cases by which transmission is occurring in different types of built environment. This is yet another article. I'm just going to quickly run through these slides to say how the evolution occurred. On the somewhere on the slide you will see a red button with the date of the month and the year. So things moved in time. So this is January 2021. We were trying to get some of the what we call the myths on the airborne transmission of SARS-CoV-2 and see what did we know, what were people talking about, and what is it that we know from a science-based reasoning on some of these aspects. It wasn't until about March 2021 that several agencies like the WHO and the CDC really put something on their website to say that yes, airborne transmission is something that we need to be aware of and take that into consideration. So WHO, to the later part of 2020, actually convened what they called an Environment and Engineering Control Expert Advisory Panel. I had the privilege of being part of this group. Several of my other colleagues who work in this field were part of this group. And the idea really was to say, okay, very quickly within that period in 2020, what can we present as viable options or recommendations in terms of the ventilation. It's a ventilation roadmap. I'm sure some of you who may have used this, you would know the approach that was taken here. It was looking at healthcare settings, residential buildings and non-residential buildings, and two types of buildings again in each, meaning naturally ventilated and mechanically ventilated. So it had a kind of a roadmap really for each one of this category of buildings and the type of ventilation system that was applicable to them. Well, here WHO in April 2021, they had some of this information clearly stated on the website about the airborne transmission route. I'm just putting these things in perspective to give you a chronological evolution of how the understanding developed through the COVID-19 pandemic. This is from the CDC. Very clearly, the three items that are listed here, the first one is about inhalation. So inhalation is about the air carrying the very fine, small droplets and the aerosol particles that can potentially contain the infectious virus. So the risk of this transmission is greatest when we are within short distance, within 3 to 6 feet or 1 to 2 meters, that sort of a distance. So we are really addressing, apart from all the other, I suppose, advisories that came about in terms of what one needs to do from the contact or droplet transmission mechanism, the airborne transmission mitigation techniques or strategies started to evolve quite clearly in terms of advisories like what you're seeing here. May 2021, a Science article, there was this very clear message that this group of 36 I mentioned earlier, we conveyed this through a scientific, I suppose, discussion to say that we need to have a paradigm shift if we were to combat indoor respiratory infection. And we're talking about SARS-CoV-2, and who knows, in the future, there could be other viruses, other agents, pathogens that move around within the built environment, and the air could be a mechanism by which it may move from one location to another. So we're basically saying that we need to look at the whole design, operation, and the consideration that goes into primarily the ventilation aspect of it. So this, I'll come back to this later towards the end of my presentation here, but just to give that chronological relevance here, it was I would say the middle of the last 3 years in terms of the time from May 2021. Some other interesting articles. This is again from my colleague here in my department. He led the study. The most interesting outcome or finding of this study was fine aerosols produced by talking and singing. Is the vocalization activities that lead to this release of fine aerosols. And here in this particular study, they're able to show very clearly that activities like talking and singing or laughing loudly contains more SARS-CoV-2 copies than coarse aerosols. That means the fine aerosols are more than the coarse aerosols, and they may play a significant role in the transmission. Something that maybe all of us were intuitively aware of and we were mindful. We would say, if you're in a group, not to sing loudly, perhaps not to sing at all. There were lots of restrictions being imposed in several places where, choir singing and concerts and, performance activities of that nature. The simple reason being it could be transmitted through the fine aerosols that get released when somebody is singing or, talking loudly, singing and chanting if it is some other prayer type activities. So these are all very clear, I suppose, cases, instances where we were very mindful that yes, the airborne transmission is probably one of the biggest concerns that we have to be mindful of. After that rough chronological movement from January 2020 to about the middle of 2021, about that same period, I did mention that the ASHRAE did come up with quite a bit of recommendations and advisories. The primary vehicle through which all this was happening was the ASHRAE Epidemic Task Force. I'm sure some of you may be aware of it. You probably were involved in some way or the other. Several teams were established as a very large group of people working in different teams. I happen to be in two teams that's shown in red, the residential and the applications team. Again, the idea was we tried to translate all that we knew from science-based understanding and analysis, whatever was available, and new information being produced, to translate that into what we call actionable measures. What can people do at the time when everybody was very concerned as to what should be the right method of operating a building or even entering a shopping mall? Or should we be concerned when we are in enclosed environments? And the biggest concern would be the message that came out through all these discussions was the ventilation aspect of it. And I won't go into that part of it much because in Europe, I'm aware that several recommendations, guidelines that said, okay, let's track carbon dioxide levels and perhaps use that as a means to give everyone an idea of how good or bad the ventilation in a particular building is likely to be. ASHRAE Epidemic Task Force produced this very useful infographic, and I used it a lot. I still use it whenever I get a chance to go into it to get some details. These are all very clickable icons. The buttons, when you press the particular one, you go into the details and learn more about what's in there in terms of the recommendations and advisories and even background information. The most important to me on this particular slide would be the core recommendations, which really was very meaningful. On one page, the primary message of what needs to be done was communicated very, very clearly. And that's what I show you on this slide. It's basically what you see on the ASHRAE website as well, on the Epidemic Task Force guidance notes. What it essentially talks about is you need to provide a minimum amount of outdoor air for ventilation. And then you can use the concept of cleaning or disinfecting in some form or the other the room air and use that to, as part of your additional, I suppose, clean air or equivalent clean air that is being delivered. So this is interesting what we now have in terms of the recommendation that you see here, the core recommendation, compared to what even ASHRAE said and Riva said back in early 2020. At that time, we did not know too much about SARS-CoV-2. So we were kind of erring on the conservative side, if you like. And we said, let's not recirculate because we know the virus is likely in the room air. And we said, let's not even do anything to reduce the ventilation. So don't do demand control ventilation. So I think our understanding of what's happening within the room air movement, the room air distribution has evolved to a stage to the last, I would say more like through 2020 and a good part of 2021, where the advisory could be modified to say you don't have to always have 100% outside air. You need to have an increased level of ventilation with outside air, no doubt about it. And that's captured. If you look at number 2 here, it said provide and maintain at least the required minimum outdoor airflow based on whatever the applicable codes and standards are. And then bring in this element of filters, air cleaners, whatever one can come up with. And it's quite likely in some instances you can take everything from outside air. And we don't have that luxury here in Singapore, at least in not most of the time. I say not most of the time, because the last few days here in Singapore has been extremely pleasant and it's been raining. The weather is very, is unlike what we normally see here. So you have certain parts of the year in Ireland, I would imagine, where you can take 100% outside. Is what we call economizer cycle of operation from a HVAC perspective. It's the free, use of air from outside. You can take more of it, and that works. So all that is encompassed in this particular page as core recommendations. Notice number 3, air distribution. And my talk today will focus a little bit more on the air distribution from a very localized air distribution perspective, because it is all about managing the air movement and the air distribution in the breathing zone of a person. So air distribution has been highlighted in the core recommendation, and we know from our basic understanding of how the HVAC system functions. It's one thing to say we take a certain amount of outside air for ventilation at the air handling unit. It's yet another thing how that air actually reaches the occupant in the occupied zone. And remember 62.1, the ASHRAE standard 62.1, we talk about minimum ventilation, outside air ventilation in the breathing zone. So it's all about how much of that outside air, now you translate that with clean air or replace that with clean air, how much of that clean air we can get in the breathing zone. So my talk is going to be, for the rest of the slides here, I will be talking to address that particular point about the air distribution. Very quickly, I mentioned about 62.1. There are several standards and there are several other documents that ASHRAE produced, have been producing over the years, relevant to important issues that we are experiencing in the world. Indoor air quality, infectious aerosols. There's one that was produced with SIPSI, ASHRAE and SIPSI on the resiliency of the built environment. And I'm sure all of us here would understand and we appreciate the fact it is all about resiliency in the built environment that is going to become so critical if we were to manage the issues of indoor air quality, i.e. the pandemic related issues or outdoor pollution related issues, and combine that with the challenges and our need to make everything sustainable. So I'm really thinking in terms of we can't just do one and ignore the other. We got to look at the two together, and that's where the dynamic changing systems or flexibility in system design and operation becomes very critical. And we talk about some of those things in these position documents as well. I can't exactly say which one talks about what aspect of it, but you get the idea that these are position documents that ASHRAE produces, providing the general, I suppose, awareness and understanding of what the current issues are, what is ASHRAE saying about it, and a good number of these documents also talks about the required research that needs to be done to get more information and perhaps more solutions towards it. I alluded to the standards, the ASHRAE standards. These 3 standards are very relevant in the context of this particular topic of today's webinar. 62.1, 62.2, and 170, you know what they are used for. The sum and substance of it is you can think in terms of providing ventilation air, minimum outside air, and all 3 of them, one way or the other, would also address things like local capture or source control, which is really the basis of what we call the indoor air quality procedure in standards. In other words, rather than just relying on ventilation to solve the problem, we say, can we go a little bit deeper and identify what the problem is in terms of particular contaminant, or in this case, the virus, or any other issue that happens in the breathing zone? And if we can manage that by controlling it at source, we can, probably even use less outdoor air for ventilation. All those approaches are described in detail, and this is not the time for me to go into details of any of those, but these are the relevant standards in this context. I showed those three standards, and I'm really trying to focus on the first two, the 62.1 and 62.2. What do these standards really base the numbers on, or what do we really pin it on? They are minimum ventilation rates. They are based on comfort and indoor air quality acceptability. Should there be health-based ventilation standards? Should we really go towards that? Health-based ventilation standards. Ventilation rates for reducing the risk of infectious aerosol transmission, like the SARS-CoV-2 or any other infectious aerosol that may, impact the society in the future, the world in the future. And I'm sure you have seen this news very recently, published on the ASHRAE website, just early December. ASHRAE is committing to developing an IAQ pathogen mitigation standards. It's called, if I remember correctly, the number is 241P. A committee will soon be set up, even as we are talking today and we are at this webinar. It is my understanding that there will be this committee that will be set up soon. And the news actually goes on to say that ASHRAE would like to have this thing developed in very quick time. 6 months, if we can do that, that will be great, because we do need something that moves from what we know in terms of simple recommendations, advisories, to what can actually be done as best practice in the industry. So a standard like this will be extremely useful, valuable to people all around the world, irrespective of what climate they are in, what types of buildings they're going to be looking at. We use this principle right through the COVID-19 pandemic. And the logic here is we refer to this infection control pyramid, as we call it. It's adapted from the US CDC. If we can eliminate the pathogen, that's the ideal. And we didn't manage to do that with SARS-CoV-2 for a very long time. And it stayed in the air. It stayed in different parts of the world. It was known to be more prevalent in enclosed settings which lack ventilation. All this understanding evolved quite clearly. We couldn't eliminate. If you can't eliminate, what can you do? Then comes the engineering control, which is where ASHRAE has a very strong role to play. We as professionals, engineers, designers, we can play our part in trying to come up with designs, control, operational control, and the way things can be managed. Hopefully we're not going to be doing this all the time in terms of, extra amount of outside air, extra ventilation. We need to come back to some kind of normalcy. We keep saying that it's a new norm or new normal after COVID. And ironically, we are still not out of COVID yet. We still keep reminding ourselves that the virus is still not gone. The pandemic is still not, we're not out of the pandemic yet. So a lot of things that happen in buildings, in transportation settings like buses, trains, and aircrafts, people are mindful of, the issues that can happen in enclosed settings, especially when ventilation is not to the level that we are expecting it to be. So engineering control plays a very important part, and I will be talking a little bit more about the ventilation, and that's the topic of the detailed topic that I will be addressing in a short while. Then we have administrative controls and the full PPE at the individual level, and we're all very familiar with it: masks, gowns, gloves. The reason I show this slide is it's never just one strategy. You can't solve the problem with ventilation. We can't solve the problem with just PPE. How long can people be wearing masks and treat that as normal function? That's a challenge. It's always a bundle of strategies. And I think that the message that I really want to get across here is we need to look at the whole issue in a holistic manner and come up with several options that will help us manage the things most effectively and in a manner that also allows us to switch between strategy 1 to strategy 2 to strategy 3 and so on. This slide again, or somewhat similar to this, you may have seen it in other talks or presentations by others as well, is just to communicate that we have in a typical HVAC controlled building, supply air that brings the air into the room, then we have return grills, and potentially this person is infected, then these are susceptible people in the, other susceptible people in the room. And we talk about the short range distance and the long range distance. So the sum and substance of this slide here is it's never a particular size of the particles or the infectious particle that's going to come out of an infected person's exhalation or singing loudly, talking loudly, coughing, or whatever. So when it is released, it's always a continuum from very fine particles, less than 5 microns, all the way up to 100 microns in size. The larger ones fall down due to gravity, easy to understand. So we maintain that minimum distance. We are not going to be affected by the contact mechanism in that sense. However, because there are fine particles, small size particles released as well, and they exist in this range too. And if you have the right kind of air movement, air circulation, things can move everywhere else in the room too. So we talk about long range transmission within a room scale. You can see this as a small meeting room, a large open plan space, multiple rooms where air connects one room to the other. So all those things that we are all very familiar with, and that's the concern that we had. And once you understand and appreciate that airborne transmission can happen, then we can think in terms of solutions that addresses these problems. So room air distribution, the point that ASHRAE's core recommendation spoke about as an important consideration, what is the current practice and how is it evolving? If you look at the current practice, mixing ventilation, something that we again can relate to, ceiling supply, we create a fully mixing ventilation profile, mixed airflow as we call it, and the air quality in general. Forget about the infectious aerosol context. Even in terms of general indoor air quality, we say everywhere in this volume of space, the air quality is the same. So that is that is what is happening in a mixing ventilation. Then if you have displacement ventilation, you supply uh, at the floor level or the lower part of the wall, depending on what kind of displacement ventilation we are strategy we are using. And this allows us to release the release the particles from within the infected person straight up into the return or exhaust grill location. So you can see that we can, if designed properly and operated properly, make use of displacement ventilation strategy or even underfloor air distribution strategy to help us remove the contaminated air, the exhaled air from the infected person. There are concerns if it doesn't work properly. You have the horizontal transmission that can potentially cause more problem than solving the problem. So concerns had been expressed in the early days of the pandemic about DV and underfloor and those kind of what we call stratified air distribution patterns, creating more challenges, more problems. And I mean, if you look at it in the overall analysis, if you let everything mix elsewhere in the room, so it's diluted equally everywhere in the room, perhaps it's not a bad strategy after all. However, once we dilute everywhere in the room within the room context in the sense that we just spoke about, it also needs to be removed out of the room. So we can't just use mixing ventilation and say that everything is diluted from the localized zone. There has to be a proper exhaust air ventilation, outside air coming in to exhaust that room air is an important part of the overall air distribution, resulting in how we can manage using simple conventional air distribution strategies. So I just spoke about the importance of ventilation. That's what this slide is really talking about. Let me now come to the advanced room air distribution, which is really the main purpose of what I want to talk about in this webinar. Airborne infection control, primary reason why advanced room air distribution is important. Enhanced indoor air quality during what I call the peacetime or the non-pandemic time. You would still want to get better indoor air quality to the people in your building, and we want to make sure that the building can actually, talk about improved air quality for everyone and not just 80% of the people or 90% of the people. we can do better than just trying to conform to certain minimum, or rather only to a certain percentage of the occupants. In other words, we can aim to satisfy everyone in the building by trying to handle the challenge or the problem at individual occupied zone. And that's where the advanced air distribution strategies in terms of personalized ventilation comes in. A lot of research has been done by several groups worldwide. We have been involved in this for almost like 20 years now. There are other groups in Europe and US and other parts of Asia. The primary purpose, again, is to ensure that we can manage the microenvironment better. And what we notice here is, this is just an example from another research kind of presentation I do purely on personalized ventilation. This is talking about increased ventilation effectiveness. For instance, these 4 bars refer to experiments that were done when we use personalized ventilation. This is the background temperature of the room, and this is the personalized air right in front of the person, the breathing zone. That's what these numbers here talk about. 26 background, 23 in the breathing zone, and then we provided the 15 liters per second per person or 7 liters per second per person. Notice when we use personalized ventilation, the effectiveness is really very, very good compared to when we only use mixing ventilation, right? No personalized ventilation is pretty low. It's about 1 everywhere in the room is about the same. It's another study here. I will not go much into the detail of this, just to give you an example that we actually tried this in an actual demonstration building where we were able to install personalized ventilation and underfloor as a combination strategy. And this part of that room or that large space was displacement ventilation. And we were comparing with the conventional mixing ventilation, a typical standard design that you find in most buildings. I just wanted to focus on the colored rings that appeared here, the green ones and the sort of red one. The green numbers, as you can see, the air exchange effectiveness, these are for the personalized ventilation underfloor combination and the displacement ventilation stratified airflow arrangement. The effectiveness values are significantly higher than when you were looking at it with pure mixing ventilation strategy. The idea again here is the fact that if you can manage the supply of air into the breathing zone very, very directly, we can do better things in terms of the exposure control, because it's all about managing the exposure to any contaminants in the individual breathing zone. Personalized ventilation, the idea then moved on to, at least in our group, we started thinking, if we can supply clean air to the person, can we also not extract exhaled air, the contaminated exhaled air for the person? So I had a PhD student who actually wanted to explore this topic. I'll come to that. This is just a list of the work that's been done by other groups of people who are focusing on managing the source control aspect of it. In other words, can we do local exhaust? So we did a study back in our own group, this almost some 10, 11 years ago. We said, can we integrate personalized ventilation with personalized exhaust for enhancing the IAQ and the airborne infection control? So I'm just going to show this one image to give you a sense of what the whole idea was. Imagine that this is actually a patient walking into a consultation room to see a doctor. So there's a certain distance that's maintained. Usually you would have a table here, much wider than what we are showing here. The idea is the infected person, the patient, releases exhaled air that's filled with infectious aerosols, pathogens that we do not want it to reach the doctor. Short of having something very targeted in terms of local control, you expect the room air to just mix everything everywhere. So you go back to the mixing ventilation concept. So she studied here, Dr. Yang Chun Ching, that's the person, my former PhD student. She wanted to explore different extraction strategies that can be integrated with the chair, like a top exhaust or side or shoulder exhaust. And we were trying to install this on the chairs of both the doctor and the patient, trying to figure out what works the best. The idea is patient exhaling we don't want much of that or any of that, if possible, to reach the doctor's inhalation zone. So several experiments were being conducted as part of that study, and that was a photo image of our experimental setup. This one is just a schematic diagram. The idea, you can see there's a displacement ventilation possibility in that room that we had at the time of the study, mixing ventilation. So we could either do displacement ventilation, mixing ventilation strategy as the background room air. And then we had the possibility of supplying clean air directly to the person's breathing zone, personalized ventilation. And we added this feature called the personalized exhaust. And the exhaust is something that is integrated or fitted with the chair. So the chair moves forward or backward, the exhaust moves with it. So it's a volume, an individual control volume for the infected person, the patient, that is managed with the patient, wherever the patient moves within that finite degree of freedom in a consultation room. The study was motivated to try and see, in a typical, say, COVID-19 setting, in a hospital or a clinic, you have the consultant, the doctor staying in a room, not a very large room, and then you have several patients visiting the consultant for consultation, any ailments, illness that they may have. When the person first comes to the doctor, we may not have had, done the enough analysis or testing to say that the person should be isolated. Perhaps in today's context, the procedures may evolve, may already had evolved during the COVID-19. Not everyone can just walk into a hospital. There's a whole series of, administrative protocols to be filled, that you are well and you are not coughing and all those issues. Let's say that in a post-pandemic situation, a few years down the track, we are back to that kind of normal situation where the hospitals and the clinics will still receive patients, but on examining the patient, you can diagnose that maybe there's something more, detailed that needs to be tested. In other words, in a typical consultation room setting, the doctor or the healthcare professional is constantly exposed to things that can move from the patient through the air. And that was the motivation of the study. Can engineering control, can the HVAC design and operation incorporate a mechanism by which the doctor can be protected from the air distribution impacting the transmission of any aerosols, any exhaled air from the patient? That was the motivation of the study. So I will not go through the details of this expression here, enough to say that there's something that we determine called the personal exposure effectiveness. And there are only three parameters. We measure what the person is breathing in here in this case. And this particular objective here was to see that by using the personalized ventilation and combining with the exhaust, can I ensure that the clean air always comes toward? In other words, I'm using the exhaust as the means to pull the clean air towards me. It was not exactly an infection control related study at this stage, but the idea was, can personalized air helps to, be pulled by the exhaust or suction in the chair. But the more interesting study was the next slide that I'm showing you here, where you have the HP or the healthy person, that's the doctor. IP, the infected person, is the patient. So here is the patient. We have breathing thermal mannequin. And this is a simple mannequin. Mannequins don't come cheap, so we couldn't afford two breathing thermal mannequins. So this mannequin representing the doctor, we want to ensure that this doctor is protected from the exhaled air from the patient. I'll explain to you the logic of it. Walks through the door into the consultation room. The doctor is seated behind the table in the chair, and several configurations can exist. The red is the patient, green is the doctor. You could potentially see a situation like this sitting at 45 degrees, at 90 degrees, or the doctor is standing to do an examination. So we did this study in a typical to be expected case scenarios. Other indices were used. We used indices like intake fraction, how much of the exhaled air from the patient reaches the doctor. That's the ratio, is the intake fraction. Exposure reduction is how much of that exposure is achieved. In other words, the exposure reduction being an indicator to determine how good or bad a particular air distribution strategy is working. So I'm just going to very quickly go through the key findings here. 3 slides, 3 key findings. Personalized exposure effectiveness increases when we have the exhaust connected to it. You can see the numbers going up. That's very clear, both with mixing ventilation in the background and displacement ventilation. This probably says it all very clearly. Intake fraction, remember I mentioned to you how much of the exhaled air from the patient reaches the doctor. Smaller the number, the better it is. N means there's no exhaust. The number the doctor will be exposed to is much higher. The moment we introduce a top exhaust device or a shoulder exhaust device of some amount of liters per second of exhaust air, the numbers come down significantly. And it's the same in all the 3 configurations that I explained to you earlier, at 45 degrees position, 90 degrees position, or when the doctor is standing to do a physical examination. So intake fraction clearly is reduced when exhaust is used in the chair for the patient. Exposure reduction. Look at this. When we have personalized ventilation only clean air supplied to the doctor, we notice about 20 to 50% improvement. Exposure reduction only about 20 to 50%. The moment you bring in the exhaust for the patient, do a bit of source control in an effective manner, it jumps up to about 70 to even 80, 85%. And that's again true for top exhaust or shoulder exhaust. So if I just put these indicators as to what we would desire, the combination of personalized ventilation, personalized exhaust helps us to increase the personalized exposure effectiveness, lower the intake fraction, good thing to have, improve or increase the exposure reduction. All this we have been able to quantify, and our publications carry all the details of how this was done. So I'm now down to my concluding remarks. What I really spoke about here, after going through a very quick overview of the evolving COVID-19 situation, the typical or conventional room air distribution practices, mixing ventilation, displacement ventilation, underflow air distribution, looking at some of at least the ones that we were focusing on as advanced room air distribution, personalized ventilation systems and local exhaust system, that really is the way in which we believe we can incorporate source control in the occupied zone or in the breathing zone of the occupants to ensure that better exposure control can be achieved. And then the findings, I did have to go through it very quickly. I only focused on 3 key findings, but this was a study that was done over a 3-year period. We have several publications in it. For those of you who are interested, I have provided the references in the handout that I'm sure the chapter will be sharing with the participant. Feel free to go and look at some of those detailed information. I come back to this concluding slide, which is about that Science article that I said came up around about the middle of 2021, I think it is, in terms of the timing, where we spoke very clearly about the need to enhance ventilation. Need to look at ventilation systems not as a static design and operation, but as the flexible system. In other words, it has to be resilient enough to adapt from a particular requirement at one time to maybe something else at another time. We didn't even speak about the situation when the outdoor air is extremely polluted. At times like that, you may not really want to take too much outside air. Just take the minimum and see what we can do with the recirculated air in terms of cleaning and local filtration or whatever that might be. So in that article, these 4 images that you see here really talk about the several things that I spoke about through this presentation here. Occupancy, the way people are seated, the way people occupy the space, the individual microenvironment control, demand control. We don't want to take a large amount outside air, having penalty on energy and other sustainable aspects of the whole discussion that we are always talking about, but do it in a way that we can manage the problem when it arises. So it's a resiliency in the operation. Improved air distribution. The bottom 2 images are the main focal points of what I spoke about here. We need to look at better air distribution strategies, focus on the microenvironment. And of course, personalized ventilation is also mentioned in this article as a way that we can enhance things and make things better in the built environment. Thank you for your attention. I'm going to stop sharing my screen and pass the screen back to who's going to take the MC role
I
here?
will take the
Howard?
MC. Thanks, Chandra. Thank you, Chandra. That was a really interesting talk. We have some interesting questions put into the group chat. We don't have a huge amount of time left, but we'll try and get us through as many as we can. So first out was Lillian, who asked a question that's very close to my own heart. Is it possible to use CO2 level for the risk of infection?
Uh, yeah, this is an interesting question that keeps coming up, and people ask if you measure the CO2, can that be used as a measure of the risk of infection? My take on this will be CO2 can be used to give us an indication about the extent of dilution or ventilation that is happening in the wherever we are. The first point is, where is the CO2 measured? I mean, do we measure it in the place where it counts the most? So if we are measuring in the occupant breathing zone, perhaps it's still, to me, a measure of the ventilation provision and how that can be translated into, are we having enough dilution occurring, consistently over a period of time to ensure that things don't accumulate in that zone or in that microenvironment. So it's a difficult question to answer to say yes or no. There are several things that need to go right. We need to understand the air distribution strategy. Is it a mixing ventilation? Is it a displacement ventilation strategy? And that again will be linked to where the CO2 is measured. If we have a good handle on all of these aspects, we can probably try and translate it in some level of measure.
Yeah. Would I be right in saying, maybe to paraphrase Lillian's question, that we can use CO2 as a proxy, but of whether our ventilation system is operating as we expected?
Yeah, at this exactly, you're right, Howard, on that point, because this is exactly what Riva advocated sometime during the later part of 2020 or early 2021. There was a lot of interest in trying to have the CO2 levels measured in buildings and being even displayed so that people entering a building know exactly what the level is and they can make their own judgment. Is it safe to enter a building? I mean, I have done measurements in buildings, different types of buildings though, where you see numbers, CO2 numbers in the range of 800 to 1000 to 1200 ppm. I've also done measurements consistently over a period of time where you have CO2 levels of the order of 3000 ppm. Now we can draw our own inferences which one is the better environment from a ventilation perspective. Surely the 3000 ppm CO2, and these are residential settings, classrooms, rooms, even in the commercial setting where you don't have a targeted a mechanical ventilation provision, things don't quite work the way we expect it to. Air doesn't come through the gaps. We think there are enough gaps, infiltration can take care of it. It doesn't work. It doesn't happen. So so CO2 to me is a good indicator to say how good or bad the ventilation system is designed and it's operating.
Mhm. Edith has asked, and I think this is the very much the the golden uh, end goal for everyone is, may I ask please, is there a feedback on this point on the life of the virus in the air or on surfaces?
Okay, good question. I mean, I've asked this question myself several times. I'm not a virologist, I'm not an expert in this field, but my understanding as it goes is um, there probably is some sort of, we need to have some understanding about how long the virus can stay in the air. But I suppose the concern always has been, if you have an infected person in a room, and if that person's state of release of this infected particles is not just at any one point in time, but is going to be over a period of time. In other words, I mean, we ask people to isolate and stay in quarantine simply for the reason that during that time they could potentially be shedding virus for an extended period of time, right? So in that sense, not knowing the status of every individual or every occupant in a building, when we have the virus in the air in the city or in the country, that's when we say cases are rising and there's all this increase in numbers that can take place. We have to make the assumption that during the normal operation of that day or the few hours in that particular space, it is a good idea to take the notion that, yeah, I mean, the air, we should try and remove the virus from the air as much as possible, either removing it and throwing it out or treating it, filtering it and cleaning it. So I am probably more clear in terms of if it is in the air, what we can do and what will help us. I probably have to take a pass in saying, do we know the answer? I don't think we know. I've not read anything to say that the life in the air is going to be only so much, not in any definitive manner. There had been some studies published in 2020. I recall seeing some of them, different surfaces, different materials, the life can change, but you always see that at a finite point in time. Within the 3-4 hours of that usage in the space, if an infected person continues to stay there, the first release, we talk about its transmission, its pathway, it hits the surface. Yeah, maybe there is a life that we can talk about. But then by the time that life runs out, more is going to come through the air. So my thinking is, unless we address that issue of the moment it's released from the person, we are able to extract it or clean it. Imagine, that's why the masks have always been advocated to work the best. The N95 mask, it controls and keeps it without it getting into the airstream a lot.
I think we just have time for just one last question, I suppose. Well, one last quick answer, I think, probably. It's from Connor. How do we choose the right type of air cleaner? Hospital grade air cleaners, for example, the Campfill City M, other filters are available, are quite expensive, but do use certified H13 HEPAs. Most claim HEPA quality filters, but then offer washable HEPAs. And others claim that the use of HEPA filter material, which is a very different thing, Connor, as your exclamation point suggests. Is there a list of recommended air cleaners? I think is the question.
Again, I suppose the question is motivated in the context of COVID, the SARS-CoV-2. I'm not aware about a list of recommended air cleaners for this purpose, although I have seen in some places, in some countries, they recommend air cleaners in general, depending on the type of, I suppose, contaminant that they can handle the best. For instance, for PM 2.5, there's a particular recommendation that can come. Even in Singapore, we talk about MERV 14 filter to be used even before the COVID-19 started. We've been having this requirement in our local code of practice. That was motivated by excessive outdoor air pollution that can occur at times of haze and those sort of situations. So when the outdoor air is polluted, you're talking about PM 2.5 being controlled. Now the question that we are really asking here is, the virus doesn't move around, what we say in its totally exposed form. It is embedded within an aerosol particle, and that particle size could be 2.5 micron, 5 micron, or whatever. So if we have a MERV 14, it can help to some extent. H13, I believe that, I mean, you're talking about HEPAs here. Better than the MERV 14s are the HEPAs, and they have been some of the things that they have been recommended for use in the COVID-19 context too. However, the ASHRAE, if I recall correctly, the ASHRAE recommendations, I'm not sure if it specifically says where it should be. It gives some information about the extent of efficiency or efficacy of the different MERV rated, say MERV 11 and above, going all the way up to the HEPA. But I'm not sure if there's a list that I can relate to that I've seen somewhere as a recommended list of air cleaners. But it's a good question. We do not know the answer fully, and we are still trying to find exactly how things move around in a typical building and air distribution system, because every building is unique. There are unique challenges. We assume things move a particular way. Other things might be obstructing its movement, and where do you place that? I mean, to me, a bigger question will be, where do we place the air cleaner in an occupied space, in an open plan space? How many do we need? How do we ensure that the clean air delivery rate that comes out of the air cleaner is always targeted towards the place where the person's breathing zone is, not where the occupant's chair is or seated, because it's all about how it reaches the breathing zone. So there are several of these technical questions that we still need to figure out as to what the best mechanism might be. Good question though.
Okay. Okay, we're just running low on time now, so unfortunately there are some other questions there, and I don't think we'll get a chance to reach them. But I'll just close up by saying our next seminar will be on the Thursday, the 16th of February, so a little less than a month from now. It's going to cover airflow management for best practices for data centers. We can continue the conversation beyond this meeting. We have a Twitter. You can follow us on Twitter and make comments there if you at us, and we'll attempt to look at them. Or we're also on LinkedIn. But we do invite you all to get involved. If you haven't already joined ASHRAE, you can join ASHRAE at on our website, ashrae-ireland.org. We do look for corporate sponsorship. I'm sure if you're listed in there or on here, we may be contacting you to talk to you about that. PM Group our sponsors, and we find it very, very helpful for us. But also on our webpage, there's plenty of resources there, but also on ASHRAE's main website, but also on ASHRAE Ireland. And if you want to follow us, as I said, we're on Twitter and LinkedIn, but we also have a YouTube channel. There's plenty more resources on there, so we do invite you to come and have a look at that. And you can subscribe and get updates as well. We would finally like to thank all of our sponsors and our supporters, and indeed yourselves coming along today, but especially to Professor Chandra. I think thank you very, very much. That was an incredibly interesting talk.
My pleasure.
Thank you, everybody. Goodbye.
So if I can add in, Chandra, thank you very much. And thank you, Howard, for chairing the session. So thank you, everyone. The recording will be available later after the seminar. Okay. Thank you again.
Great. Thank you, everyone. Thanks a lot.
Thanks, everybody.
Bye.
Bye.
So, Howard, well done.